Hello there. The activity for today is to do a little warm up using a little unit circle knowledge, and then to go over some transformations of functions review. First off, we'll give you some time to pause me and see if you can't do the six trig functions for these two angles. Pause me, pause me, pause me. Do it fast. Okay. 495 is, let's see, 495 minus 360 is 135. So that is a 45, 45, 90 reference angle. That means I'm looking at negative radical 2 over 2 and positive radical 2 over 2. The sine is root 2 over 2. The cosine is negative root 2 over 2. The tangent is negative 1. And now the cosecant, I'm pretty sure, like, double check that you know how to get from 2 over root 2 to square root of 2. That's rationalizing the denominator. In the same vein, that's going to be the negative radical 2. And then reciprocal of cotangent, negative 1. Part B, the negative 60, that's going to be in quadrant 2, and that's going to be a 1/2 over and negative radical 3 over 2 down. So my sine, negative radical 3 over 2, also known as the y-coordinate. The cosine is the x-coordinate, 1/2. And now the tangent, this sometimes takes a little work, but I'll give you a nice little hint here. When you have two fractions in a ratio, or one fraction over another, and the denominators are the same, you invert and multiply, of course, but those denominators are going to kind of be eliminated. So at the end, you really just have numerator over numerator, negative root 3. It's a nice little shortcut. Confirm it if you need to. Okay, negative 2 over root 3. This is 2, and the cotangent is negative 1 over root 3. You should rationalize those. I'm going to keep going because the main focus here is transformations of functions. You've done it in Algebra 2A. You've done a little bit of it in Algebra 2B. And so you should be, well, it's been a while, but every function, no matter what, can be broken down into a combination of transformations. These numbers here represent different transformations that can happen. On the outside transformations, those are vertical, either a vertical stretch or dilation or compression, or shifting up or down. On the inside, that B and that C represent a horizontal move. If it's here where that C is, it's either a left or a right, and that the B represents either a horizontal compression or stretch. So there is another link to get to a little deeper dive into that, just to kind of review. But this is where we'll kind of assume that you're okay with or coming back to those pieces. So in this example, we always have an original function, and in this case, it is the dotted one that's f. So f is the original, dot, 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 that's the original. And then in each of these, something's happened to change it. The three graphs show three different transformations. Explain verbally what transformations were done, and then write an equation. So that's what you do first, is you kind of look and see, okay, how has f changed into g? I look at the x, or the coordinates here, and they are lined up vertically. So that tells me that there's not been any horizontal action. So then I kind of see, like, okay, this is the point 0, 1, and it's gone to 0, 3. This is the point 1, comma 3, and it's gone to 1, 5, 6, 7, 8, 9. That is a vertical stretch by 3. A vertical dilation. So g of x equals something happened to f of x. It has been stretched vertically. We put a 3 out there in front. That means it is a vertical dilation. All the y-coordinates have been tripled. The y-coordinates of the f have been tripled to get to g. In the second one, the f function, now the coordinates are still lined up also, but there hasn't been much of a visual change. In this one, things have been stretched. This function that has only had a span of 1, 2, 3, 4, 5 now has a span of 10. So that's how we kind of decided that it was a vertical stretch. In this one, this second one, it's the exact same figure. It's just been raised up. So that means it's translated vertically, or we can say up. How many is that? 1, 2, 3, 4, 5, 6 units. And when that happens, g of x is an outside change. So it is the original f of x, but then we just add 6 to it. That means all the y coordinates have been added, have been raised up 6. Last one on this page. Ooh, I'm seeing definitely there is a horizontal stretch movement here. And then that the f function has been brought down. So let's kind of see what that looks like. Here's one way to see it. From the left part of f to the right, there's 1, 2, 3, 4, 5, 6, 7, a span of 7. And then from over here on this bottom one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm dressing 12, 13, 14. It's a span of 14. So I know for sure that that function has been horizontally stretched by 2. Horizontal. And once that happens, then I can kind of see like, okay, once I've stretched the function, so this point goes out 4, 5, 6, then what is this span? If you count it down, all of them have gone down 7. So then we translate down 7 units. So in this case, there's 2 transformations happening. The g function is the original x, f of x, but it has gone down 7, and it's a horizontal stretch. Now this is where it's hard to remember. Things on the inside are kind of the opposite intuitively of what you think. So if you want to stretch something horizontally, you actually multiply the x coordinates by 1/2. So that takes half as long to get to the same spot. And then I go down 7. Those are my transformations on that first page. G of x equals f of 1/2 of x minus 7. And you can always double check. Like if you want to find g of, for example, let's say g of 3. No, let's make it a little bit easier. Let's say g of, let's say g of 2. I'm going to do that because that makes me put in a 2, 1/2 of 2 minus 7. I end up taking f of 1 and then taking away 7. I look at where f of 1 is, and that's 3, and then I go down 7. Wait a second. Oh, yeah. So f of 1 is 3, and then I go down 7. That's -4. So the point 1, 3 goes down to 2, -4. All right, well, now that this second page, it is just kind of taking you through a couple of the transformations that are going to happen. Now, I think you have answers to it, but I'll take you through, I guess I'll explain through each one, but I would encourage you to at least pause here and kind of take a look and see what happens from the original to get to the new one. What happens to the original? Write it down verbally and then put it into equation form. From this one, number 1, it is the exact same look. It's been translated down 6. So that means g of f is the original. g of x is the original f of x, down 6. Number 2, it looks like the exact same f shape, but it's just been taken that many to the right. How many has it been translated? That is the point 5, 4 to 15, 4. Looks like it's gone 10 to the right. That means it's g of x is f of x minus 10. It means I've translated everything over 10 to the right. Okay, this one looks like it's a much larger kind of V shape here. It has gone from the original, let's see, from -6 to 2, and now it's gone from -6 to 6. That tells me it is vertical stretch by 3. So that is 3f of x. 2 more. Can you see what's happening here in number 4? The y coordinates are exactly the same. They are level with the original. So that tells you that there's nothing happening vertically here, but it's a horizontal stretch. So this is a horizontal stretch by, we just have to find out the stretch factor. How do you find out? STRETCH. This is the point here, 5 and 4. And this is the point 10, 4. What's happened from 5 to get to 10? It's a stretch-wise, it's a doubling factor. We want to horizontal stretch that baby by 2. How does that show up in the equation? F of 1/2 of x. Now this final one is you're combining 2 transformations. See if you can't decide by pausing what's happening verbally, and then try the equation. No, I'm serious, try it. Pause, pause, pause. I take 1 point here, and I've gone to get to the next one. I double it here this way, and then boom, boom, adding up 3. This one down here, this bottom of the kind of the arc, has gone from 5 to the right to 10 to the right, and then 1, 2, looks like up 3. We are stretching horizontally first by a factor of 2 and translate up 3. To first horizontally stretch, that's f of 1/2 of x, translate up 3. Here's where we're going with this, everybody. In pre-calculus, you're doing the unit circle. You are going to find that the sine, cosine, and tangent, and all the 6 trig functions have a sinusoidal curve that in many cases can be stretched, shrunk, or compressed, reversed or flipped, and then compressed or translated. That's what we're going to be doing to those. So you don't know it now, but there is a cosine of x. And so now you can almost see that if g of x is an original like cosine 1/2 of x minus 3 plus 2, for example, and we could put like a 4 in front of it, you can identify before you even know what cosine really looks like, what that function is, that is a vertical stretch by 4. We've done a horizontal stretch by 2. We've gone to the right 3 and up 2. That's where we're headed. All right, thanks for watching.